Okay, question 8 says, consider the curve given in parametric form where x is equal to t cubed minus 12t and y is equal to 3t plus 1, and t varies from negative infinity to infinity. And part A says to compute the derivative dy dx, your answer should be in terms of the parameter t. So in light of our discussion in the last video, we can compute dy dx in terms of this parameter t by finding dy dt and then dividing that by dx dt. Okay, so computing those derivatives, we find that dy dx is 3 divided by 3t squared minus 12. And there's a common factor of 3 in the numerator and denominator. And so simplifying, we find that dy dx is equal to 1 over t squared minus 4. All right, so moving on to part B, it says find the equation of the tangent line of this curve at the point negative 11, 4. All right, well, the first thing I want to know is that if we're at this point negative 11, 4, what's the value of the parameter t? And to find that, I'm going to go ahead and set x, which is t cubed minus 12t, equal to the x-coordinate of the given point, and that's negative 11. And then I'm going to set y, which is 3t plus 1, equal to the y-coordinate of the given point, and that's 4. And so in particular, looking at the second equation, I can solve for t easily, and I find that t is equal to 1. And note that if I plug t equal to 1 into the first equation, on the left side I get 1 minus 12, and that is negative 11. Okay, so we are at the point negative 11, 4, when the parameter t is equal to 1, and so I can find the slope of the tangent line to our curve at this point by evaluating dy dx when t is equal to 1. So plugging t equal to 1 into the expression for dy dx that we found in part A, I get that the slope of the tangent line to our curve at this point, negative 11, 4, is equal to negative 1/3. And so then, to find the equation of the tangent line to our curve at this point, I can use point-slope form. Y minus the y-coordinate of the given point, and that's 4, is equal to the slope, that's negative 1/3, times the quantity x minus the x-coordinate of the given point, which is negative 11. So this is x minus a negative 11, so x plus 11 in parentheses. And then rearranging, we find that the tangent line at this point is y equals negative 1/3 x plus 1/3. All right, great. So now let's go ahead and check this out on Desmos. So here in blue is our curve given in parametric form up here. And now if I hit play on this tracing point, I find that as the parameter t increases, I'm moving along the curve as you see here. All right, now here's our point negative 11, 4 in red. And here's the equation of the tangent line that we just found, y equals negative 1/3 x plus 1/3. If I graph that line, I find, yes, it is tangent to this curve at this point. So it's working. All right, now for part C, it says, at what point or points on the curve is the slope of the tangent line equal to a 12th? Well, the slope of the tangent line is dy dx, and so I'm going to start by setting dy dx equal to a 12th. And then from part A, that implies that 1 over t squared minus 4 is equal to a 12th. And so taking reciprocals to both sides, we get that t squared minus 4 is equal to 12. And adding 4 and taking square roots gives us that t is equal to plus or minus 4. Now to find your locations at these two values of t, just plug those values of t into these equations for x and y. So when t is equal to 4, x will equal 4 cubed, which is 64, minus 12 times 4, which is 48, and 64 minus 48 is 16. The y-coordinate would be 3 times 4, which is 12, plus 1 is 13. So when t is 4, we're located at the point 16, 13. And likewise, when t is negative 4, we're at the point negative 16, negative 11. All right, so let's check that out on the graph. Take these out here. So there's 16, 13. And there is negative 16, negative 11. And so from this picture alone, it appears that the tangent line to this point 16, 13 appears to have the same slope as the tangent line of the curve at the point negative 16, negative 11. Now, if I graph the line with slope 1/12 that passes through this point, and then likewise at this point, I get these two lines. And yeah, it appears that these lines are in fact tangent to our blue curve, right? And they have the same slope of 1/12, so it's working. All right, and that leaves us with parts D and E, and I'm going to go ahead and make some space there. So for part D, it says, at what point or points on the curve is the slope of the tangent line undefined? The slope of the tangent is dy dx, and this will be undefined when the denominator, t squared minus 4, is equal to 0. And that happens when t is plus or minus 2. And just like in part C, I can find our location at these two values of t by just plugging those values of t into these equations for x and y. So when t is 2, we're at the point negative 16, comma 7. And when t is negative 2, we're at the point 16, comma negative 5. All right, let's check those out. So take these out of the picture first. So here is the point negative 16, 7, and here's the point 16, negative 5. And I can see that at these 2 points, the tangents are vertical, right? So their slopes are undefined. Okay, in light of our discussion in the last video, okay, if I think about our tracing particle at these 2 points, the horizontal component to the velocity of the particle is 0. Okay, we're only experiencing a vertical velocity at these 2 points. All right, cool. And then for the very last part, this is E. It says, what happens to the slope of the tangent line as t approaches infinity? Well, the slope of the tangent line is dy dx, which is 1 over t squared minus 4. And as we let t approach infinity, the denominator, t squared minus 4, will approach infinity. And so 1 over this expression approaches 0. Okay, so the slope of the tangent line, dy dx, approaches 0 as we let t approach infinity. So going back to this picture here, okay, as we increase the parameter t, we're moving along the curve in this direction, and we can see that the tangent to the curve will have a slope that's approaching 0, right? So in other words, right, the tangent line is going to become more horizontal as we move along the curve in this direction. All right, great. That's going to do it for this question. And I will see you in the next video where we'll solve problem number 9. All right, thanks.